So let me give you an example. If we go back to our original curve that we graphed, we in fact have what's called a relative maximum at the top of the hill and a relative minimum at the bottom of the hill. Now, what's the difference? Why do we call it a relative maximum or a relative minimum? Well, that's because when we notice that this function has the arrows on the ends, and so these continue onward, positive in the upward direction and the downward direction. So there is no maximum value that we get out of this function because it keeps going on forever and ever and ever. In the positive y direction, keeps going in the negative direction on forever and ever. So there is no absolute maximum or minimum in this particular function. There's no lowest point and there's no highest point. But there are relatively high points and relatively low points. For a relative maximum, we would say in its neighborhood of other points, it's the highest point. And same thing for the relative minimum. In its neighborhood of points, it's the lowest point. Again, if you think about this neighborhood idea, in your neighborhood, you know where the largest house is in your neighborhood. Does that mean it's the largest house in the city you live in? No, not necessarily. It could be, but it's not necessarily. But at least in your neighborhood, it's the largest house. Same thing for the smallest house. Smallest house in your neighborhood may not be the smallest house overall, but in your neighborhood, it's the small. So it's relatively small, or the largest house is relatively large. Okay, so we're going to keep that in mind. Now, what I want you to keep in mind here, and I'm going to go back a little bit, okay, is the fact that if we notice what's going on to the left and to the right of our relative maximum, slopes of the tangent lines to the left are all positive, right? Because we're increasing going up to the relative max. And then to the right, they're all negative. They're decreasing, okay? So that's exactly how we're going to determine when we have a relative maximum or minimum. It's going to be, we're going to find our critical values, okay, critical numbers. And then we're going to test for positive derivatives to the left, negative derivatives to the right. Similarly, for a relative minimum, again, we've got a critical number here, right? Place where the derivative is 0. In this case, it's going to be the reverse. We have negative derivative to the left and positive derivative to the right. So all we're going to do is take what we just did for testing for increasing and decreasing, add one more step to say if we go from positive to negative at a critical value, that critical number has to be a relative maximum. Or if we go from negative to positive in the derivative, then at that critical number we have a relative minimum. Okay. If they're the same sign to the left and to the right, then we don't have either. We do not have a relative extrema. Okay. So let's go ahead and put this to work. So we're going to take the function f of x equals x to the 4th minus 12x cubed, and we're asked to find all relative extrema of this function. So relative extrema is just sort of the umbrella term for relative maximum and relative minimum. So we want to find all our relative maxima and all our relative minima. All right, so we're going to follow our steps for determining increasing and decreasing. First is points of discontinuity. Do we have any points of discontinuity here? No discontinuities. Another polynomial, which is continuous everywhere. Number 2, find the derivative. So it's going to be 4x cubed minus 36x squared. Third, find critical numbers. That's going to be where the derivative is 0, where the derivative is undefined. Okay, so if we set 4x cubed minus 36x squared equal to 0, let's see, I can factor out a 4x squared. That leaves behind an x minus 9. So that would mean, let's see, either x squared has to be 0, so that means x is 0, or x minus 9 is 0, that means x equals 9. Okay? Since we have no discontinuities, these are both critical numbers because they are both numbers that are in the domain of our function. And x to the 4th minus 12x cubed is defined everywhere. It's another polynomial. I'm sorry, that's not what I want. Not that function. We want 4x cubed minus 36x squared. We want that to determine whether that's undefined anywhere. But it's not. It's defined everywhere because it's another polynomial. Okay. So it's defined everywhere. So we only have two critical numbers. We have no discontinuities. We have two critical numbers. So our chart is just going to use these two values. Okay. So let me go ahead and create that chart and fit it in down here. I have 3 intervals. F prime, test value, sign, and increasing or decreasing. Okay, so our intervals are going to be, let's see, the leftmost value is 0. So it's going to be negative infinity to 0, and 0 to 9, and 9 to infinity. Okay, so test value. Something between negative infinity and 0 would be negative 1. Something between 0 and 9 would be 1. Something between 9 and infinity would be 10. So I want to plug this into, again, I'll circle our derivative, 4x cubed minus 36x squared. And you can crank out your calculator to do the test here, but let's see. So 4 times x cubed, it's going to be 4 times a negative number minus a negative number. That's going to be negative. And in fact, again, like I said, if you want to plug that in, it'll be negative 4 times 36 is negative 40. Okay, plug in the value 1, it'll be 4 times 1 minus 36 times 1. So 4 minus 36, that'll be negative. And then we've got, plug in the value 10. So 4 times 10 cubed, so that's 4 times 1,000 minus 36 times 10 squared. 10 squared is 100. I get 400, so that's positive. So this is decreasing, continues decreasing, and then it's increasing. Okay. So if we sort of graph this, it would be decreasing, decreasing, and then increasing. Okay. Very, very roughly drawn. Okay. Very, very roughly drawn there. All right. So that wasn't the question I was asked. The question I was asked was to find all relative extrema. Remember, our test for relative extrema is, do I change from decreasing to increasing, or do I change from increasing to decreasing? A change in sign from one side of the critical number to the other. So there's no change in sign as we go from the left to the right of 0, but there is a change in sign as we go from the left to the right at 9. So I do have, down here at the bottom, a relative minimum. Okay. So I have a relative minimum at x equals 9. And in fact, the relative minimum value is f of 9. Okay? So that'll tell us, if I plug that back into the original function, that'll tell us exactly how low that point really is. So if we do 9 to the 4th minus 12 times 9 cubed, 9 to the 4th minus 12 times 9 to the 3rd. That is negative 2187. Okay. So the relative minimum is at x equals 9, and the relative minimum value is f of 9, which is negative 2,187. So that's how low that point goes. Now notice I didn't plug that 9 back into the derivative, because what happened at the derivative? It was 0 there, right? So I need to plug that 9 back into the original function to find out exactly how low that point really is. Okay? The derivative is only used to create the chart. Whatever values you get out of the chart, you're going to need to plug those back into the original function.